Okay, so now let's look at the calculation side. We have the formula for radius minimum radius, okay, and we also have the table in ATJ, Arahan Teknik Jalan, specifying the minimum radius for respective design speed. So for the sake of this exercise, let's calculate it first. The minimum radius, the variables are the design speed v, and in our case is 30 kilometers per hour, and you have E maximum, which is the maximum super elevation, and that is set at 0.1%, 0.1, okay, which is 10%. And then you have F max, which is the maximum side friction of the tires. So you put in the values into the formula, you get the minimum radius is 26.2 meters. So when you look at the Arahan Teknik Jalan table at the back there, the recommended minimum radius at 30 kilometers per hour design speed, the minimum radius is 25 meters. So let's just use the smaller value. So you use the minimum radius at 25 meters. And here is the super elevation development length, which is LSD. Some people say that LDS, same thing. So the variables are N, which is the normal crossfall. In our case, the normal crossfall is 0.3, 0.03, 3%. And then you have the super elevation here, E is 10%, 0.1. And here the speed, design speed, 30 kilometers per hour. So you calculate the LSD, you got 43.3 meters. Again, we check at the Arahan Teknik Jalan. It is mentioned that they recommend the length of the spiral, the LSD, to be 48 meters. Okay, so we'll just adopt LSD 48 meters. Okay. Next, we calculate the planned transition length, LT, transition length. So LT is 2/3 of LSD. Okay, so we get 32 meters here. Okay, so the value of LSD is 48 meters and value of LT is 32 meters. Next, we calculate the chainage of tangent points leading, meaning that the first segment of the curve. Okay, I show you here. This segment, leading end of the road. Okay, because we consider our design is from here, so this is the leading section. All right. So take chainage at TP leading equals to 25, which is the length that the chainage that we measure previously, and plus 35. 35 is the value of the length over here. So chainage 25 plus the length here 35 meters. And then the formula R tangent delta over 2. Okay. So you calculate the value, you get the chainage of TPL, tangent point leading 35 meters. So the TPL is at chainage 35. Next, you calculate the chainage at tangent point tailing. Okay, so this is the tangent point leading chainage, which is 35 over here, plus the length of curve. Okay, so this is the formula of the length of curve. You need to convert the value of delta here into radian. So you get 74.3. So the two tangent points, the leading tangent point is at 35 meters, and the tailing tangent point is at chainage 74.3. So you mark these points on your map. Tangent point leading, 35 meters. Tangent point tailing, 74.3. Okay. Okay, next we calculate for the leading, this is not, leading, tailing, okay. Chainage at the leading end for the point of TS, SS, and SC. Okay, tangent to spiral, spiral to curve, start of spiral. Okay, so the chainage for TS leading. Okay, so you get the value from chainage tangent point leading here, 35 from the previous calculation, minus half of LT. Okay, half of length of transition. You get 19 TSL. Next, calculate SC, spiral to curve leading. Okay, same formula but plus. Okay, plus LT divided by 2, you got 51 meter. And then you have SS, start of spiral, which is this value over here, you minus with the LSD. So you get 3 meters. So 3 meters, 19 meters, and 51 meters. So you mark on your map SS leading 3 meters, TS leading 19 meters, and SC leading 51 meters. Okay. Next, we calculate the tailing end. Same points, but on the other side. The difference is just plus and minus lah. This one, instead of minus, you add. Okay, chainage of TPT plus LT over 2. So you get 90.3, and chainage SCT minus 32 over 2, LT over 2, 58.3, and SS point is 106.3. Okay, so SS is 106.3, and then 90.3 and 58.3. So let's have a look. The point of SS 106.3. TS is missing because I forgot to mark. Okay, and then SC is 58.3. So you need to mark all these points along your design section. Okay, so what you can see here, so this is the existing road and this is your road. SS marks the point where the pavement start to transit. Okay, the transition of the normal crown. Okay, the normal crossfall. Okay, so we do not want this point to lie outside of your road. Okay, so meaning that when you turn into your road, the first segments, maybe first few meters should have the normal crossfall, 3.3% to the left, 3% on the right. Okay, after a few meters, you get your the starting point, the SS point. Okay, so from this point, the super elevation will start to develop until it reach the point of SC, where maximum super elevation started. Okay, so the only circular portion in your curve is between these two SC. From SS to SC here is the spiral. Sorry, the spiral is from here, TS to SC. But the development of the super elevation starts from here, SS to SC. Okay? Okay. Next is the calculation for uh, vertical curve.